Hey guys, what's happening? Today we are going to be simplifying expressions, okay? So if we have an expression like this, it tells us we're going to multiply, right, this times this. We're going to simplify that, okay? So go ahead and copy this down and we'll get going. All right, here we go. This says x squared times x to the fifth. What is x squared? Well, x squared is x times x, isn't it? Times x to the fifth, isn't that x times x times x times x times x? Okay. And so what do you end up with? You have 1, 2, 3, 4, 5, 6, 7 of those x's, so that's really x to the seventh. Okay. But here's the cool thing, and the reason I'm showing it to you this way is because once I show you this cool thing, you're probably going to start getting it all confused because you'll forget the basics. If you can remember this right here, that this means this and this means this, all together you get that, you're going to be fine. Basically it says add powers. So if you look, we have x squared times x to the fifth, okay? If it tells us to add the powers, take a look. We have x to the 2 plus 5, and that's x to the 7th. So we get the same thing. Okay, but this is a better way to actually see it. This is more visual, okay? Let's do another example. We have x squared y to the negative 3 times x to the fourth and y to the fifth. Okay. All right, notice everything is being multiplied. Now some of you guys see the dot right here that tells you to multiply. Don't forget, if you don't see a dot, you know, if there are two things crunched together like that, you're still multiplying. So basically what you have here is an x squared, okay? You have an x to the fourth, you have a y to the negative 3, and you have a y to the fifth, and they're all being multiplied. Now the reason I wrote them together like that is so it's easier to see that now you have an x to the power of 2 plus 4, and a y to the power of negative 3 plus 5, and now you can combine them, x to the power of 6, y to the power of 2. Okay, and we're done there. Okie doke, let's do part B, dividing. All right, and in this type of problem, we're going to move the smaller power then subtract. All right, we're going to move the smaller power then subtract. And I'll show you what I mean by that. Okay? Here's an example. All right, we have x, let's do w squared over w to the fourth. Okay. All right, so it says move the smaller power. What on earth do I mean by that? Well, let me just show you what this means really quick. We have w squared, that's w times w, over w to the fourth is w times w times w times w, right? Okay, and so basically, can't I cancel one of those with one of those, and one of those with one of those? Which leaves me, what's in the top? If everything canceled, it's not 0. If everything's canceled out, it's like 5 over 5. What does that become? 1 over 1. So if everything cancels, you have a 1 divided by w times w is w squared, right? Okay, so that's what our answer should be. So let me show you what I mean by move the smaller power. I'll do it right here. W squared over w to the fourth. Which one's smaller? It's this guy right here, right? This guy's smaller. So move that guy down, okay, and subtract. So move that guy down and put a minus 2 right there, okay? So if I move this guy down, I cancel it off, and it becomes 1 over w to the 4 minus 2 is 2, okay? So that's what I mean by move the smaller power, then subtract. Okay, let's do another one here. All right, how about this guy? X to the negative 1, y squared over x to the fourth, y to the negative 3. All right, so which one, let's look at the x's. Which one's the smaller one? Well, this guy's the smaller one, x to the negative 1. That's smaller than that. So I'm going to move that guy down, right? So that's we're going to subtract a negative 1, so now it's a plus 1, right? Okay, and now let's look at the y's. Which one's smaller? It's this guy right here. That guy's smaller, so I'm going to move that guy up there. So it's a minus 3. So now we're going to subtract a minus 3, so that becomes a positive 3. Okay, so anything that I've circled is really just canceled, right? It's gone. And so now look what we have. We have y to the 5th power over x to the 5th power. Okay, 4 plus 1 is 5, 2 plus 3 is 5. Okay, we could do another one really quick. Here, let's do this one real fast. Example. 8x to the negative 2, y to the negative 3, z to the negative 4, divided by 4, x squared, y to the negative 4, and z to the negative 4. Okay? All right, now watch how I do this. I'm going to do it a little different than I did up here, okay? I was just trying to draw your attention to stuff when I put circles around it and drew arrows, okay? But watch what I have here. I look at the numbers first. The 8 over the 4. 8 turns into a 2. 4 turns into a 1. Hopefully that wasn't too mind-boggling. All right, now look at the x's. Which one's smaller? Okay, this guy's smaller, right? So it's a negative 2. Okay, so watch this. I'm going to cross it off. Okay, since it was negative, I'm subtracting a negative 2. That becomes a positive 2, so I put plus 2. Okay, now look at the y's. Which one's smaller? The negative 4 is smaller, so I cross it off. Negative 4 is subtracted up here, so subtract negative 4. That's a plus 4. Okay, all right, and then finally here, which one's smaller? They're both the same. So keep in mind, if they're both the same, don't they simplify? If they're both the same, say it was 10 over 10, wouldn't that simplify into 1 over 1? Okay, so if these are both the same, cross them off. They're both the same. They simplify to 1 over 1. Okay, and now watch what we're left with. Let's just clean up the messes. What do we have left in the numerator? Well, we have a 2. Here we have a y to the negative 3 plus 4. That's just y to the power of 1. Okay, everything else is crossed off. Look down here, we have a 1, so we don't need to write it. Over, we have an x to the power of 2 plus 2 is 4. Okay, and we're done. That's how I would suggest you do it every time. That's probably the best way to handle those problems. Okay, and let's do one more example of exponents. Okay, so let's do part C, exponents. And what we're going to do here is multiply the powers. All right. Here's our first example. We have x cubed to the power of 4. Okay, and watch what happens. X cubed to the power of 4, isn't that x cubed times x cubed times x cubed times x cubed? Okay, and isn't that x times x times x times x? All right, and isn't that just everything times? So x, isn't that what it is? It is, isn't it? And what do you have? All together, you should have 12 of them, unless I didn't count right. So this gives me x to the 12th power, okay? But take a look up here. Notice exponents. If you have x to an exponent, like that, if you have x cubed to an exponent, right? What does it say? Multiply powers? Well, let's try it. X cubed, right? Raised to the power of 4. What do you get if you multiply that? 3 times 4. That's 12. X to the power of 12. So we get the same thing without all the work. Okay, so that's why people come up with these shortcuts. It's a shortcut, okay? This is why it works, okay? This is better, this is easier, but you have to remember to multiply the powers. Over here, you have to remember to add the powers. When do you multiply? When do you add? Okay, that's what you guys have to sort out. That's why I think this is much better, okay? All right, let's do a quick example really quick, all right? X squared. Sorry, let's do a different one. I'm gonna skip to the last one. We have 2 x to the power of 3, y to the power of negative 1, and z to the 5th power, all to the power of 10. Okay? All right, so all we're doing is multiplying the powers, okay? So here we have a 5 times 10, that's z to the 50. Here we have a negative 1 times 10, okay? That's y to the negative 10. We have a 3 times 10, that's x to the 30. We have a 2 right here. What do we do with that? Well, keep in mind, it says to multiply powers, okay? What's the power here for that 2? Okay, the power for that 2 is a 1, okay? So now it's a 2 to the power of 1 times 10. It's an x to the power of 3 times 10. It's a y to the power of negative 1 times 10. And it's a z to the power of 5 times 10. Okay, and so now we have 2 to the power of 10. We have x to the power of 30. We have y to the power of negative 10. And we have z to the power of 50. Okay? And then from here, all you have to do is 2 to the power of 10. I think that's 1,024. I think. Can anybody verify that? Here, 2 to the power of 10. Let's try it. 2 to the power of 10. Yeah, buddy, 1024. All right, so 1024. X to the power of 30, okay? Y to the negative 10, and z to the positive 50. Now there's one last step that I can do, and I would really appreciate it if you guys would do this too. See that guy, y to the power of negative 10? That can't be written like this. I'll show you what to do with it. We have 1024 times x to the 30. Y to the power of negative 10 means I'm gonna get rid of it and move it down to the denominator. Okay, so this guy, y to the power of 10, y to the power of negative 10 turns into y to the power of positive 10 if you flip the sides. And then we have z to the power of 50. Okay, and that'll be your final answer. So long story short, anytime you see a negative exponent like that, switch the sides. So if it's in the numerator, it goes to the denominator. If you see a negative exponent in the denominator, it goes up to the numerator. Similarly, watch, we did it over here, right? If we had a y to the power of negative 4, right? Didn't we cross it off and put it up in the numerator as y to the power of positive 4? We did it right there, right? If we had x to the power of negative 1 right there, didn't we cross it off and put it down in the denominator as x to the power of positive 1 right there? Okay, so that's all we're doing. If you see a negative exponent, switch the sides. All right, guys, good luck. I'll talk to you soon.